Hi everyone, my name is Summer, and this is my just presentation of my final senior project in sacred geometry. It's been a really great class. I just want to express my gratitude for the course. This is, you can even see it from here, my not geometrically precise first attempt freehand Sri Yantra. But I'm actually really proud of it because I wanted to approach this design for a long time, even before I applied to CIIS. So when I found out that this is our school's symbol, it was really exciting. And then when I saw sacred geometry was being offered as like a final elective option for my final semester of the accelerated bachelor's of art in interdisciplinary studies, I thought that would be a beautiful way to end the school year and complete the degree. So you can see here, this central point here, that's called the Bindu. And I want to draw a really exciting parallel between the Bindu and the monad, which was a concept that came across in this class for me that really struck, which was just a very elegant geometrical representation of the monad, or the originating being of the universe. And here we have this concept of the Bindu in the circle, which then forms the whole Sri Yantra forms around it. And Yantra is literally means like a vehicle or a vessel, and is considered to be a sacred design that can potentiate meditative states, and also has a lot of deep philosophical connotations. The upward pointing triangles refer to sort of the masculine or unmanifest qualities of the supreme being, and the downward facing interlocking triangles represent the form, the manifestation, the goddess, but also the entire symbol represents a goddess herself. The Sri Yantra is considered to be a goddess, a supreme goddess of the universe. So I've always really loved this design and thought it would be a great challenge, as I'm interested in sacred geometry paintings, which I've shared in class. So I found some instructions that were really amazing. They were like, here are just some free form instructions, make a circle about here and here, draw some lines, and then just start constructing triangles. So you can see in the center, there are 9, including the center triangle, there are 9 interlocking triangles. And this is the original triangle here of the construct, which ideally should be a perfect equilateral triangle. You can also see in the basic symmetry operations that we covered in our first module, the Sri Yantra is a really graceful and elegant example of reflection symmetry. Because if you were to fold this whole a design in half and then expand it back out, you would realize that ideally the one side is a perfect mirror reflection of the other side. So I love the simple and elegant mirror reflection of this design. I also chose this design because a lot of the positionality of academic education in our country and in Western countries sort of starts with the West. But this design dates all the way back to the Harappan civilization. And I think that's really important to note, and I'm going to write about it a little bit in my final paper. So in the Indus civilization of the Harappan, we have dates of 2500 to 1700 BCE. And if you compare that to what is attributed to Greek mathematics, there's the two eras of Greek mathematics. The classical period in Athens, which is about 600 BC to 300 BC, and then the height of the center of mathematics when it moved from Athens to Alexandria, when Alexander the Great built that city in Egypt. And then before that too, we have African universities in Ethiopia and in Kemet in Egypt. So I think it's really important to question the positionality that starts knowledge and mathematics and learning with the Greeks, since we already have these ancient civilizations that I'm sure educated and informed the Greeks. And there's a lot of evidence that Greek scholars traveled to Africa to learn, and that also there were these incredible civilizations in the Indus Valley. Right now there's amazing scientific research going on with this design specifically that's used in computer science, They're just uncovering incredible things about this design that are beyond the scope of my expertise, but I might touch in on my paper a little bit, as well as taking some of the mathematical principles that, and with what we know about antenna construction, all kinds of fascinating things that I'm going to be learning about, delving into a little bit more in my research paper, just to honor the ancient fountain of knowledge on our planet Earth. And it's okay that we don't attribute everything to Western civilization. It's a relative newcomer in the history of our species. So I want to honor Africa and Asia and pre-existing civilizations, as well as the developments of the Greeks and Plato and Aristotle, because and the interconnectivity of ideas. So the bindu in this should ideally be precisely in the center of this circle. Mine is not, and then we have these errors of margin. But I'm proud of my errors of margin, because in order to really understand what something precisely is, I find it useful to have a reference point to what it is not. So this was my first attempt. It was intuitive and mostly freehand. I did use a ruler. This triangle, I haven't measured the angles, but should ideally be 60, 60, 60 degrees. So thank you for letting me share my project, my presentation. I'm going to develop this more artistically when I have time to really enjoy that creative process. And anyway, I thank you for allowing me to share where I'm at in this process with you all today. And we'll see you for our final conference on Saturday the 14th.